All right, this is a video on solving rational equations, and we'll start off with an introduction and then do a few solved examples. So the definition of a rational equation is an equation with at least one rational expression as part of it, but not necessarily composed entirely of rational expressions. So as an example, we might have an equation that looks like this: x plus 2 over 2x squared minus 3 plus x squared plus 4 equals 5. So you can imagine maybe we wanted to solve for x in this situation, and to make a connection with the definition I just gave you, this is a rational expression. This is a quadratic expression, right? And so a rational equation in this case is not composed entirely of rational expressions, but it definitely needs at least one rational expression in there. Let's do a few examples here, and this is going to connect to the work we've done before, where we're really looking to simplify as much as we can through addition, subtraction, maybe multiplication. We'll be getting common denominators, just applying all those skills that we've been working on. So what I suggest doing here is working towards common denominators so we can add the two fractions on the left side of the equation. I'm also going to factor the denominator on the right side of the equation so that we can see what those common denominators need to be. So let's go ahead and do this. So I will multiply this fraction by x plus 3 over x plus 3. I can multiply, let me make some space here. I can multiply this fraction by x minus 3 over x minus 3. And I can rewrite this right-hand denominator using the difference of two squares as x plus 3 times x minus 3. And I think you can see that once we do all that multiplication, we will have common denominators. So let's go ahead and do that, and I'll do the distributive property at the same time for the numerators on the left side. So I have x squared plus 3x over x plus 3 x minus 3 plus x squared minus 3x over x plus 3 x minus 3. And that's going to all equal 2 over x plus 3 x minus 3. Okay. What you can really think about doing at this point is multiplying both sides by that common denominator. So we're not multiplying top and bottom at this point. We're simply multiplying both sides by the same thing to keep our equation balanced. So let's multiply both sides by the product x plus 3 x minus 3. And that will cancel out those denominators. We're going to have to remember that we did that down the road, because we can tell right now that x can't be a negative 3 or a positive 3, because it would give us denominators of 0. So if we end up getting a solution of positive 3 or negative 3, we need to recall that and realize that that would not be an actual valid solution. So let's go ahead and simplify a little bit here. We have x squared plus 3x plus x squared minus 3x all equals 2. Our 3x's cancel. We have 2x squared equal 2. Divide both sides by 2. X squared equals 1. So x is going to equal plus or minus 1 here. Okay. In this case, we need to, again, like I was alluding to before, double check and make sure that positive and negative 1 are both valid solutions in terms of denominators, and they are. If we were to plug in positive or negative 1 anywhere in our original fraction, we would get valid answers. So that's our solution right there. Let's go ahead and do one more. And in this case, we're going to do something similar. It looks like we have to factor the denominator on the left-hand fraction. Looks like we will be getting common denominators as well. So let's rewrite this equation with that denominator factored. And at the same time, I'm going to multiply the other two fractions by the appropriate values to get common denominators. So I will do 2x over x plus 2, and I'm going to multiply this by x plus 1 over x plus 1. and that is still equal to x minus 1 over x plus 1, and I will need to multiply that fraction by x plus 2 over x plus 2. All right, so it looks like we're going to have common denominators. So what I'm going to do now is multiply both sides by that common denominator to eliminate the denominator. So I'm going to multiply both sides by x plus 1 times x plus 2, and that's going to cancel out these denominators and leave us with something a little bit simpler and more manageable. So on the left side, we're going to have an x minus 1 plus, I will do the distributive property here, 2x squared plus 2x equals x minus 1 times x plus 2. Okay, so we're closer, but we still have some work to do here. We will multiply the two binomials on the right and do some simplifying on the left. So the left side turns into 2x squared plus 3x minus 1, and the right side turns into x squared plus x minus 2. So let's go ahead and, looks like we have a quadratic to solve, so I will force the right side to be 0. Let's get the right side to be 0 by subtracting some things away from that right-hand side. So subtracting away the x squared leaves me with an x squared on the left. Subtracting away an x leaves me a 2x on the left, and adding 2 to both sides gives me a plus 1 on the left, and that all equals 0. All right, let's factor and solve this quadratic. So we have x plus 1 times x plus 1 equals 0, meaning that x is equal to negative 1. Okay, you might think we're done. You might think, yay, we got it, we solved it, x is equal to negative 1. We need to check to see if this value of x results in possible 0 denominators. So looking way back up here, if we were to plug a negative 1 into that denominator right there, we would end up with a 0 in the denominator, which violates math law, not allowed. So in fact, this equation has no solutions. So that's one thing that's interesting about quadratic or rational equations, is you might go through all the proper steps, you might think you have a correct answer, but you need to check it to make sure you do get valid solutions, that we don't have these anomalous solutions that result in 0 denominators. I'm going to show you one more strategy here, and just a little tech tip, solving by graphing using Desmos. So this equation here, we have 2 over x plus 2 plus x over x minus 2 is equal to 1. And so just a quick reminder of how to use a graphing calculator, and it doesn't have to be Desmos, it could be any graphing calculator. Let's set the left side equal to y. Let's set the right side equal to y. Let's look for an intersection. Okay, on Desmos we'll do that. And we're going to look for the x coordinates of that intersection. That's really what we're trying to solve for, is x. But then what we will need to do is check denominators at the end. Okay, so let's go ahead. I already have this typed into Desmos. I'll go over there. I'm not able to annotate my Desmos app, so I'll just talk you through it, and then we'll return to this screen in a moment. So I have the left hand of the equation written as a y equals, and the right hand of the equation written as a y equals as well. And if I were to find the intersection points of those two functions, it looks like we won't reach an intersection as we go left. Those look asymptotic, and similarly as we go right. So it looks like the only intersection we have also happens to be the y-intercept. So the x value is 0, okay? So let me copy that over to my note app right quick. And so just to be clear here, that's our solution. We don't really care about the y value. typed in y equals 1 as that horizontal blue line, right? But what we do care about is the x value, so x is equal to 0. So that's the solution to this equation, and then what we're going to need to do is just check to make sure that this works. And what I'm going to do is actually plug in 0 into the original equation to make sure we get an equality equal to 1. So as a check, is 2 over 0 plus 2 plus 0 over 0 minus 2, is that equal to 1? Okay, so simplifying a little bit, is 2 over 2 plus 0 equal to 1? It is, and it checks out. Okay, so that would be our solution. X is equal to 1, and we checked it. Nice, we got through it, and that's a good place to stop right there.